Good evening, dear learners. Lesson 2 of our discussion on factorization is underway. Today, we are going to look at how the learners would be able to factorize 4 terms, how learners would be able to factorize 6 terms, and how learners will be able to factorize 2 complex terms. Let's set the ball rolling with the first question. 2ax plus ab plus 2mx plus mb we are supposed to factorize. 1. Let's not forget that in our previous lesson we learned that factorization has to do with resolving the number of terms of an expression into factors. So if we have 2ax plus ab plus 2mx plus mb and we are supposed to factorize, then we are supposed to resolve these into factors of which the product should result back into the expression we have. So if you have a question of this nature, we are going to split the 4 terms into 2. And what we are going to do is we first have to check if there is a common term between the first 2 and the last 2. If there is no common term, then we would have to rearrange. So 2ax and ab has a common term of a, whilst 2mx plus mb has a common term of m. Therefore, there is a common term in the first pair and the last pair. So therefore, we can go ahead and use the idea of what we learned in lesson 1 to factorize the first pair and use the same idea to factorize the second pair. So we take 2ax plus ab, 2mx plus mb. So with the first 2 terms, we realize a is a common term. So as we did in our first discussion, we would have to divide the first term by the common term. A divides itself 1, a divides itself 1. We have 2 times 1, 2 times x, producing 2x. Our second term, ab, dividing the common term a divides itself 1, a divides itself 1. We have 1 times b, producing b. Now the next pair of terms, we can see clearly that m is the common factor in the next pair of terms, and we factorize m out. In doing so, then now we are going to divide 2mx by the common factor m. M divides itself 1, m divides itself 1. So we have 2x, and we divide mb by the common factor m. M divides itself 1, m divides itself 1. We have positive b. Now, after we have been able to factorize the pairs, we realize that we have resolved the 4 terms into 2 terms. Now we are going to factorize these 2 terms using the same idea of factorization as we learned in our lesson 1. So if you observe carefully, this is a complex 2 terms that we have. We realize that the 2 terms we have has 2 parts each. The first part of the first term has to do with a multiplying 2x plus b. And the second part has to do with m multiplying 2x plus b. So we are going to look out for the common factors in these 2 terms. We realize clearly that 2x plus b is common in the 2 terms. So that would be factorized. So 2x plus b is factorized out. Then to get the terms inside our bracket, we would have to divide the first term, which is a, 2x plus b, divided by the common factor 2x plus b. So 2x plus b divided itself once, 2x plus b divided itself 1. So what is common, what is left is a. So we take the second term plus m into bracket 2x plus b, dividing the common factor 2x plus b. 2x plus b divides itself once, 2x plus d divides itself 1. We have m times 1 producing m. In this case, we have resolved our 4 terms into factors. Mind you, if you use the idea of multiplication of 2 binomials, of which we'll treat in our lessons ahead of us, you would get back to 2ax plus ab plus 2mx plus mb. So we have resolved the 4 terms into factors. If you take a critical look, we are going to work on the second question, of which the third and the fourth would be trials for my students. The second question has 6 terms. We have 2mx plus 2nx minus my minus ny minus mx minus xn. So if you have this, you realize there are 6 terms. The same idea used in factorizing the 4 terms will be used in here. But then you have to first check if we can get a number of pairs here. We can get 3 different pairs here. And the first pair is 2mx, 2nx. Second pair is minus my minus ny. Third pair is minus mx minus xn. Now check if there is a common term among each of the 3 pairs. 2mx, 2nx, x is common. My, ny, y is common. Mx, xn, x is also common. Therefore, we can treat them in pairs. So we take 2mx and 2nx. 2x is common. So we go to divide the first term by the common term, which produces m. We divide the second term by the common term, which produces n. And that is for the first pair. With the second pair, we have negative my, negative ny. We realize negative is common, and also y is common. So we divide the first term, negative my, by negative y. M is left. We divide negative ny by negative n, by negative y, the common factor negative y, and realize that n is left. We take our last 2 terms, negative is common and x is also common. So you realize from here that we can divide the first 2 by the common term negative x. Negative goes off, x goes off. We have m. Negative xn by common term negative x, we have plus n. So when you take a critical look at what we have done, we have resolved the 6 terms into 3 terms. And therefore, you watch critically these 3 terms of 2 parts each. There is a term which is common for these 3 terms. And that term clearly is m plus n. So we have to factorize m plus n out. Then we are going to divide the first term by m plus n. Realize m plus n will go off and there will be left with 2x. The second term, negative y m plus n. Realize m plus n will go off and there will be negative y. Do same to the third term, realize there will be negative x. We can decide to factorize. We can decide to simplify the expression in the second bracket. realize 2x minus x will produce x minus y. And that is how we factorize the 6-term expression we have. Dear learners, you are expected to use the idea of what we have done to try question C and question D. See you in our third lesson. Bye-bye.